here with V.N. Bringi, Professor of Electrical and Computer Engineering at Colorado State University and an expert in polarimetric weather radar. He is the 2012 recipient of the AMS Remote Sensing Prize for outstanding contributions to the advancement of polarimetric Doppler weather radar. Congratulations.
Thank you so much, Chris.
Tell us a little about your research accomplishments and your efforts to develop dual polarization weather radar.
Okay, this goes back to 3 decades ago when I was a graduate student at Ohio State University. And we were just beginning a program. And at that time, my graduate advisor suggested this particular problem to me. And in terms of research accomplishments, it's been a long history. And it's been a very step-by-step development. Originally, people were very skeptical for about the first 3 or 4 years that the idea would even work. And so we had to go and do a lot of convincing to the experimental radar meteorologists that this is something that we should do, because we didn't have our own radar at Ohio State. And it turned out that our collaboration with the British, with the Appleton Laboratory at that time, Martin Hall and Steve Cherry played a crucial role in actually implementing this scheme, and then we had a collaboration going for a couple of years. And so that's how that accelerated the progress. I'm talking about 1978 right now. And that accelerated the progress, and once people saw that kind of data, then everyone jumped on the bandwagon, and it was easier to get funding and to do our own work. And so that led slowly. By the mid-'80s, it was very well established. But it took a long time to get into operation, as you know.
Yes. And I was going to ask you about that. That's actually one of my next questions. As a leader in the development of this technology, which is now being implemented in the National Weather Service network of Doppler radars, what has you excited about the future for this technology?
Well, the future of the technology basically is to give forecasters new kinds of information that they never had before in the standard reflectivity Doppler radar that's been in existence in the early mid-'80s. And so this new kinds of information gives you 8 to 9 variables to look at. And so it's a matter for the researchers and the experts to really know what's going on, but then to transfer this technology to the forecasters is going to be the next big step. And it's going to take the National Weather Service quite a bit of work to translate the advantages, the final advantages, to the forecasters. But already the experimental version of these forecasting using these variables has caught on, and the forecasters like different aspects of these things. And as the algorithms get better, I think they're going to like it more and more. And already the tornado debris signature has been highlighted as one of the new applications that we never thought of back in 3 decades ago. So there's going to be, since there are 8 or 9 variables, people are going to come up with new kinds of ways to correlate them and look at the texture of the signals and come up with new ideas, and there'll be fresh blood coming in. So I'm sure at least for the next 5 to 10 years, the algorithms are going to be perfected and going to be more and more useful as time goes on. It's just too early to say the impact on forecasting, except in a certain areas like flash flood forecasting or for hail detection.
If you had the opportunity, what, if anything, might you like to do differently along your career journey?
Yes, my career journey came like most foreign students who came to the U.S. I came in 1972 to join Ohio State University to do a master's and PhD. Actually, my original interest was in communication theory and systems. And I came with my own funding. I came with a bank loan, a student aid from the Bank of India, which was just valid for 1 year. And in that 1 year, I had to actually come up with funding for a PhD. And so, since my interest was in communications theory and systems, I was trying to look for funding in that area, find some professor who would take me on as a graduate student and provide me with tuition and stipend and so on. I was unable to manage that, and I was just walking the corridors one day, and I came across the name Thomas Saliga, who was my advisor at that time. And at that time, the department, there was a small program in atmospheric sciences within the Department of Electrical Engineering at Ohio State, a very small program, and all it said was some fellowship might be available. So I jumped at that opportunity because I needed funding to continue to do my PhD, which was my goal. So it was kind of a little bit of a random chance that I ended up in radar meteorology. That was not my original intent. And so one thing led to another, and finally he was able to find funding, and then NCAR and a UCAR fellowship for a 4-year PhD program enabled me to continue that, and then the field was open and very exciting, so I just continued to work in that field for many years.
Well, really paid off.
It really paid off, yes.
And when you first learned you were going to receive the Remote Sensing Prize, what was your reaction?
The reaction was I was quite surprised. I just got a call from the president of the AMS arbitrarily one day in November, I think, or early December, and first thing I wanted to tell the president was I've never gotten a call from the president of the AMS in the last 3 decades I've been working, but I didn't quite say that. The president was very gracious. He said, "You won the Remote Sensing Prize," and I said, "Thank you from the, to the AMS for having honored me like this." And I was quite surprised because I had very little inkling that it was possible. It was quite surprising.
Well, what would you say to colleagues, as well as to recent graduates in the atmospheric and related scientists, asking about the merit of such achievement?
The Remote Sensing Prize is probably one of the few prizes in the AMS that was instituted not too long ago, where an electrical engineering or a physicist, a non-meteorologist by training, who cannot forecast the weather, for example, could actually get a prize with the AMS. And the last 3 recipients were either physicists or geographers or electrical engineers. So I would say to the community of physicists and engineers that there's a wealth of technology in weather, and it's going to be driven by the need for more and more accurate weather predictions and so on, and the instrumentation and the technology is going to push in some sense the way the weather forecasting is going to go. And so I think to my colleagues and students in electrical engineering and in physics and related disciplines that even if you're a non-meteorologist, there's a lot of technology in weather that is still yet to be addressed.
Well, very good. Well, thank you for taking the time to speak with us, and congratulations again.
Thank you so much, Chris.